So basically, I will present to you some research discipline which can be remotely connected to our discipline of multi-objective optimization and interactive methods. And then at the end, I will briefly tell some basic ideas how can you use this. So first of all, Herbert Simon. I think everybody in operational research should kind of know well this person and maybe even read some basic papers, know some concepts, because they're very, very basic and very fundamental and very kind of pioneering. So he is considered pioneer in AI, information processing, decision making, but basically most influential works relate to some psychological behavioral aspects. He got a Turing Award for some contributions to AI and a Nobel Prize for research related to decision making. Officially, it's kind of named decision making in economic organizations. But I could frame it, it's a kind of general concepts of decision making, how decision makers and managers set their preferences and make decisions related to some economic projects and plans. And I will just briefly remind you this concept. Basically, I think it's maybe most of you know this concept because it has direct connection to the reference point based methods interpretation. But just maybe I know that many people do not pay attention to that because basically it's not operation research discipline, it's rather economics, political science, and this kind of decisions related to economics. And initially in the classical economics, which developed long before operational research, there have been also many optimization concepts, and basically all the classical economics is based on the assumption that economic agents or decision makers are rational, that they always select best choice, they always optimize. And you may remember from economic courses that all these curves which intersect supply demand curve, some unemployment curve, prices curve, they're basically curves which are derived from some assumptions that someone selects optimal solution which optimizes something under some conditions. And in the last century, a lot of researchers questioned this rationality and proposed many different relaxations and many different other theories which take into account the fact that people are basically not rational 100%, or in some situations a lot of irrationality present. One of them, you can, of course, everybody remembers Kahneman and Tversky, also behavioral economics and many other lines of research. And so the contribution of Simon basically related to another theory which diverges from rationality conditions. It's called bounded rationality, and it's the situation where decision maker just cannot make optimal decisions, cannot find optimum because of lack of information, because of lack of cognitive capabilities, time limitations to make decisions, computational tractability. So as everybody observes, all of you probably observed in real life that some managers or someone who plans, they do not just have time to analyze everything and they just make decisions based on available information and based on the time they can spend to think about that. And Simon introduced the concept of satisficing. It's a new word. There have not been has not been this word in English language, and it's basically satisfy and suffice, and it's kind of new concept which is considered alternative to optimization, when decision makers basically, instead of optimizing, they just choose the first acceptable option, good enough option, in order to complete the solution process given the amount of time available and resources and information. So according to Simon, it's from his Nobel Prize lecture that there's still optimization and there's still this satisficing idea, bounded rationality, and they basically there is continuum between them, between these behaviors. If we have certain very simple situation, we optimize. If we have uncertain situation and complex and limitations of time, we satisfy. And there are a lot of something happens between them. In decision-making theory, this directly translated in terms of aspiration levels. So basically, I think it's very important work for all of us, because it gives us probably the best interpretation of reference point based methods. Whenever we write in the introduction that reference point is very good concept for decision makers, we kind of defend this concept. Why do we use it? We say that they have very good interpretation. And this interpretation of reference points is given by this idea that Andrzej Wierzbicki, already after he developed this aspiration, achievement scalarizing function and aspiration level technique, several years after that, he noticed that this concept fits very well to the much earlier concept which was already proposed by Simon. So this earlier work of 82, Wierzbicki basically connected achievement scalarizing functions with this interpretation. And I think it's a very useful thing, because basically here Wierzbicki describes how all these mathematical techniques and mathematical, all this big theory which we all use, how it can be derived and interpreted from the existing theory, which is also very popular and important, because it comes from the Nobel Prize winner and it's accepted everywhere. So we have decision problems, goals, and the basic setting which comes from organizational theory is that the decision maker is a manager, or if is goal setter for some organization, and decision maker sets aspiration levels and expects that the organization or staff will produce plans how to manage organization to achieve those aspiration levels, detailed plans. And then from all of that, we have the basic interpretation of how achievement scalarization function works. We can set aspiration levels not thinking about if they are achievable or not, and if they are achievable and can be exceeded, then the function, the achievement scalarizing function, or its realization in terms of the staff of the company who creates plans, then they will be overachieved. If it's not achieved, what boss said, what manager said, if it's not achieved, the staff will try to at least bring it as close as possible, to find plan which is as close as possible to the desired levels. And if it's exactly achieved, then everything is okay. So basically, very often I see And here, just in this paper, from this, Verzbitsky derives all his theory and all his formula about achieving rising function, which has been already derived in other papers. So it's just side note. It's not directly related to what I present today, but the side note is that very often when I read about introduction of reference point based methods, the first interpretation is that it minimizes distance to the reference point. But basically, first, it's not incorrect, because if we overachieve something, we do not minimize distance, but we go beyond, and we basically it's opposite to minimizing distance. We maximize distance from the point when we want to go further. And secondly, for real life decision makers, it's much easier to think in terms of the Simon's concept of satisficing in their own domain, rather than think about some mathematical distances in some space which should be introduced and learned. So basically, I recommend everybody to have this work and always refer to this work when you want to justify that reference point based methods are better than other methods. And then the next step, as part of this theory, some researchers started to think about dynamic models. And this line of research has, I just found two main papers, Leventhal and March is a co-author of Simon. And then from their paper, Theresa Land made some continuation. And the idea is that they have only one objective: to maximize the organizational performance. So basically, the manager just tells only one goal: I want to achieve a certain level of performance. So at each time point, each time period, the manager sets this goal, organization tries to fulfill it, and the setting will kind of influence how organization works in the next time period. And because of the general environment of uncertainty and of a lot of different problems, uncertainty, lack of information, problems with complexity of system, no one knows if organization can achieve this goal or not. At the next time point, the manager observes how the goal was achieved by organization and then adapts the aspiration level to a different level to proceed with organizational development, but with already new goal. So it's very simple concept, dynamic concept, and it works like that. This can be research question: how do aspirations for organizational outcome behave over time in response to experience? And the concept is very simple. It has been developed by the earlier paper, and it's just based on the simplest possible assumptions, that the manager updates aspiration levels based on the weighted average of the previous aspiration level and the actual performance, which creates this model. So basically, this is previous aspiration level.
We can't see any screen that you are sharing. Are you sharing something?
Yes.
Okay,
Other people.
See. Anyone else can see any screen? Okay. Yeah, now we can see.
Sorry, I somehow unshared it. Wow. Thank you for telling. Oh, sorry, I just I used it a couple of times. Well, I just go through basically. So Herbert Simon, and I will put this presentation to the Confluence wiki if you still use it. Or I can just send it to Kaisa, and if you do not download it, you can ask Kaisa. Or I can just send it to you.
Just to answer, yes, we do store presentation slides in the wiki, so please put there. Thank you.
So just I'm not sure if what I tell you is very basic stuff and you all know it, but I just since I didn't share the screen, so just repeat: normal rationality we optimize, bounded rationality we satisfies, and then we introduce aspiration levels, and this is that Wierzbicki paper. I wonder if I told you is something new for you, or you all read this paper. So it tells, like you see, it's 1982, so it's later paper than previous Wierzbicki papers. And in previous papers, he just introduced this concept of achievement scalarizing functions. And basically, probably he didn't know about the line of research of Simon because it's different discipline. And in this paper, he just in very good manner connected his theory of achievement scalarizing functions with this big research discipline, which was very important. And so basically here he describes everything which relates to achievement scalarizing function. He describes it in terms of that research discipline. And it's very well connected. And if you want to present your research topic to some non-mathematician, I think its best way is to refer to this paper and describe it in these terms as it presented here. So it's in this paragraph, it's basically it's presented. What's presented is the principle how achievement scalarizing function works. If a reference point is feasible, so it's can be exceeded, then it's exceeded. If it's infeasible, then it's as close as possible. Then we can tell about distance. Only in this case we can say something about that. We minimize distance. But for managers, for non-mathematicians, the distance in this space does not tell a lot of stuff. It's better just to tell directly in their terms. And from that he derives everything which was already derived in that paper. And then this part of this organizational behavior, here we do not see Herbert Simon anymore. It's just one direction of research which is inside this big theory. From these two papers, one of them somehow extends and implements the previous concept. So here I go back to when you told it. I don't have shared screen. Theresa Land poses the following research question: how aspiration of organizations behave over time in response to experience. It is the dynamic setting, so it's not our everyday research formulation, but from these dynamic settings you can I think take something for non-dynamic problems. And here the connection between two papers is that the basic theoretical model is proposed in the previous paper, and in the current paper Theresa implements this model and studies how it behaves. And this is the model. So here, what we have, why it's the aspiration level which is set at each time point by the manager of the organization. And we can see that it's just simplest model possible. The manager of the organization sets aspiration level in each time point as the weighted sum of the aspiration level set previously and the achieved goal which was kind of observed, which corresponds to this aspiration level. So she tells about attainment discrepancy. It's basically the difference between the aspiration level set and the achieved performance. Then she formulates it as a just statistical model of autoregression in order to be able to study real data and try to fit them to this model. And then maybe I will briefly tell you, okay, this is the discrepancy, this is the difference between them. So basically, if this difference is negative, then the decision maker wants to improve the aspiration levels. If it's positive, then decision maker wants to deteriorate aspiration levels. And basically, it doesn't make practical sense for me, because if the goal of the organization was overachieved, why I should decrease my kind of aspiration levels? I should use it and demand more from my organization to go further. But it's a kind of, it always weighted sum. So I improve aspiration levels. I improve my aspiration levels if the goal was overachieved, and I decrease it if it's underachieved. But when I want to improve it, here, according to this model, I set my aspiration level lower than actual achievement because it's weighted sum between them. Then it's, well, maybe it will be not very interesting, just to let you know what is the purpose of this paper. Basically, there have been alternative concepts in the economics theory and in the line of research of rational decisions and neoclassical approach when people optimize. And according to that different concept, the decision makers just set aspiration level, trying to match the expected actual performance which will be achieved in the future. So basically, the aspiration level which is set by decision makers is the prediction of what can be achieved. And all the paper is devoted to evaluating these two models based on real data and trying to understand which one of them actually works in practice. Is it true that kind of real decision makers get weighted sum between these two goals, between the previous aspiration level and the actual achievement of this level? Or decision maker just set goals according to this concept of expectation, that they just try to set exactly aspiration level which is their prediction of what can be achieved. Mathematically, it's just trivial models, but there is a lot of theory related to behavior, and these papers are very big. But mathematically, they are not very sophisticated. So I will skip these things. I only tell that in this paper, Teresa even made experiments with real decision makers, and it's called some Markstadt marketing strategy games, where real managers sit together and then they play some game, which is very realistic. And from that, she got a lot of data, how they play the game. And from this data, so basically, she estimated parameters of the models, made some statistical analysis from the data, and she tried to answer the questions, what are coefficients of the model? And from these coefficients, she tried to make conclusions which of the approach, if this adapting aspiration level or expectations approach, which of them actually works. And she made experiments with the different groups of people from different industries, managers from different industries, observed some inconsistency of the results, and made some general conclusions. For example, here you can see a lot of words learning. The decision maker learn over time, and if in the earlier stage they behaved like they adapt the aspiration level to the achievement, so the coefficients were like they correspond to the previous model. But after they learned, during this game, after they learned how it works, they rather started behaving like the second model. They just tried to set goals which exactly match what is expected to achieve. Basically, it's very interesting, all these concepts. For us, they're not directly useful. We will not use them in our studies. But it's interesting how they conduct experiments with humans and what kind of research questions do they answer, and how do they understand the learning. Sorry, I will turn it off. So, maximize organization performance. Manager sets aspiration level. Aspiration level influences the state of organization at the next time point, and manager adapts aspiration level. It's pretty interesting and pretty simple paper. What are continuations of this paper? They are pretty influential. They have a lot of citations, and I try to study mainly in the Scopus system, what kind of developments do they have. First of all, I found no multi-objective or multiple criteria extensions from these models. For us, of course, the very moment we see this model and understand it, the first thought would be, let's just take multiple aspiration levels and go to the vector space. No one in the literature, at least in journals indexed by Scopus, published, and there is no line of research of vector extension. There are a lot of models in this line of research which study different modifications of this kind of behavior, and they refer to them as agents. Basically, they mean economic agents. But in some work, you can forget the word economics, and you just can consider these works as examples of research. How can you model agent behavior based on very big, very grounded theory, and what kind of simple models you can get and behavior you can observe. So basically, another interesting, useful line of research which I found is just research related to agents, and you can maybe not directly use that research, but you can read it and see how simple you can frame agent behavior, and you can refer to those papers.
Dimitri, can you elaborate what is meant by an agent? Is it something artificial, referring to artificial intelligence, or is it some certain type of human, or
yes,
what this term is used for?
Yeah, probably this term is just one of the basic terms in economics theory. I think for us, because we work in operational research, optimizations, we are mathematicians, I think many of us did not study the just theory of economics. maybe because I studied it at the university, I have had this course. Maybe I think that everybody also had it, but actually I realized that many people never heard about these concepts. So basically in the economics theory, whenever they, from the classical economics, from the first works centuries ago, they introduce the word, the notion, economic agent. And it is just entity of real world which makes decisions. Basically, it's decision maker. And they remove the word economic. So basically, you can find in this theory a lot of works which just refer to agents, but their agents means some real life entity which makes decision maker. And I think that it's worth for, if you have spare time and if you want to kind of want to develop more profound theories related to behavior and decision makers, I think it is worth even to read Wikipedia and read about basic concepts. What is classical microeconomy, this rational approach, rational decision making? What kind of preference relations do they consider? What agents, which are, in our terms, rather decision makers, how they behave? I think it would be useful just to have these concepts, and maybe they will inspire you to something, because there is kind of a lot of indirect connections, a lot of simple ideas which you can kind of turn on some light, and also sometimes you can refer to some concepts in order to back up your assumptions. So basically I recommend very much even very basic reading. Even I read a lot of Wikipedia kind of pages, and basically currently, if we're talking about science, in Wikipedia you can find pretty much very good introduction to every topic. So here agents are initially some entities of real life who participate in economy. In consumption theory, there are people, but in some other theories, in production theory, agents can be organizations. But in those papers I'm talking about, in those papers, agents already are replaced kind of by models. So the authors of the papers still formally think that agents are those economic agents who make decisions, but they just model agents, replace agents with X, Y, Z, and then they create these models of behavior and just run those models, simulate. Basically here agents you can also consider in those papers. Agents are models of real life entities who make decisions, react to the situation, observe results of their decisions, and they make decisions trying to optimize something. So here it's also, I think, interesting for you would be to read about that, just to see how agents in the paper present model of real life entities and how this model, simple model, looks like, and what kind of conclusions you can derive from it. So here we have, let me go from here. Basically, it's also earlier, let me go back, it's earlier paper, 1903, and also this paper refers to the first paper of 81 where this model was proposed. This paper goes kind of in parallel with the paper of Teresa, and is just another option what you can do with these models. So first, and also I recommend just to have a look at it, because bounded rationality is this setting, is description of real life situation which leads decision maker to different behavior, where decision maker do not try to find optimum of something, but decision maker try to set preferences as aspiration levels. And this bounded rationality environment is a kind of also useful concept to know, because you always can refer to this when you talk with some people from other disciplines, rather from political science, and you can explain to them what is reference point methods. And this is just the setting. Well, decision making complexity. Why do we use reference points? Because we deal with situation in industry, in economics, where the situation is so complex that decision maker cannot optimize, and some other assumptions of bounded rationality. And from this, the author formulates a model which is very familiar for us. There is decision maker who is agent, economic agent, simultaneously decision maker, decision variables, and objective function. And then we see here, let me go further, yeah. Sorry, probably I could have missed it. So basically what I wanted to show you is the same model formulation as we seen in the previous paper, that the decision maker sets aspiration level for the next time point depending on the achieved result, observed result, and depending on the aspiration level set during the previous time point. I will skip all this theory, it's very similar, but what do they do here? They formulate this setting based on bounded rationality assumptions, which is derived from this Simon, all this big Simon theory about satisficing bounded rationality. And from this, they derive this kind of model where decision maker sets aspiration level and adjusts aspiration level in time by observing the achieved result and getting just weighted sum, the simplest possible adjustment. And then they often, because the classical theory of economics, which is based on rational choice theory, based on optimization, it's very influential in its basis before all these new concepts proposed by Simon, Kakman, and Tversky. The classical economics was the main concept. They always try to compare the new concepts with classical economics. And here they formulate models, make assumptions, run simulations of these models. And they, for example, try to prove here that when decision makers behave as described by this bounded rationality setting, by this new concept, they basically in time, they converge to the optimal. And so people conclude that when decision makers behave in the situation of bounded rationality and behave as satisficing decision makers, when time goes, decision maker converge to the optimum, and so in time they converge to the optimizing decision makers. This kind of simple conclusions, simple simulation tests give you results which sound very, very deep and very profound, that you connect two theories together. And it looks like that. This author created those settings of bounded rationality, made some simulations of agents, and here you can now see the simulation as the real agents, as we understand agents, some entities, some virtual entities which behave and which react on the environment and make decisions. The author made simulation of them and observed how the aspiration levels and how all these parameters converge to the optimum, and even proved some theoretical result that if you adapt your aspiration levels, then you converge to optimum. This is just another example of how this theory works in practice. When people try to kind of make new papers and publications, they do not use any sophisticated mathematical techniques. They do not use calculus. They just make basic assumptions, simulations, agents which act just by setting the aspiration levels. And from that, they get very interesting results in the sense that they sound interesting. And another kind of example of papers, they have group of agents. So here agents, both also economics agents in the classical sense and also agents in our understanding, because here they participate in simulation. They're kind of modeled entities. What do they do here? The author again takes this model that you know, uses that basic assumption of just simple weighted sum adaptation of the aspiration level. Then author introduces community model when aspiration level of each risk taker may depend on the resources accumulated by other risk takers. So basically, this is simulation of agents where each agent also looks at what other agents have. Then all those models, and then the author conducts simulation of those models and tries to see how different parameters of behavior of decision makers influence their kind of the trajectory. How do they achieve something? And basically, from this line of research, we can go towards the line of research where the authors try to understand how behavior of real life entities, people, even animals, and I don't know, bacteria and other things, how behavior evolved and adapted in order to achieve situations where the entities somehow perform in the best way, reproduce or get economic growth, and so on and so on. And authors make this kind of multi-agent models with parameters, simulate models, and try to find parameters which give to the population or to economy or to some group of people, which gives to them best results. And then authors try to speculate how real life, what we observe real life behavior, if it corresponds to what we obtain in simulation, if it's really simulation shows real evolution of some objects, and we get in the simulation, we get kind of similar results, similar parameters as we observed in practice. This kind of line of research, pretty interesting, not directly connected to our research. And well, it's already almost hour. I wanted to make it like 20 minutes presentation, so I will show you only final reference.
No problem. If you want to say a bit more, that is fine. So up to you.
Okay. So I was talking about like impact, what follows from those papers. Some other thing which I found in the literature, because those papers are famous and they were published in top journals, many people just cite those papers in order to back up their assumptions, their basic setting of their paper in the introduction, in motivation. For example, let's take this. There are very few papers in operational research which cite those papers from that rather economics research or political science research. But they often do like this, like you have just operational research paper, which is basically not connected to anything which relate to dynamic behavior of economic agents. But then you say something like this, that that behavioral research concerning aspiration levels indicates that they are function more of past aspirations and performance than future expectations, and so on and so on and so forth. So basically, this is the only citation of the paper, of that Land paper in this operational research paper, and the author does not use the results. You can see the typical operational research paper. Step 1, step 2, decision makers, group solutions, how decision makers make decisions, examples and discussions. So basically it's some framework for interactive CDM. But they kind of use it in introduction in order to make the introduction more rich, because it's citation of very big, profound paper, and to make sound it deep, that they kind of base their assumption, their paper, the premise of the paper is backed up by very big, serious research. So basically, that's all about the impact in continuation, and some simple conclusions from reading these papers. What can you get from them? First of all, it is very tempting to just get those formulas, those models, and directly extend them to multiple objectives. And see here, I have a kind of a lot of different fantasies about how can you do it. And basically, if you just see this model and you know some examples of real life methods, real life problems of multi-objective optimization and methods which are used, you can find many different ways how you can extend those simple dynamic models to multiple objectives. You can just replace the scalar aspiration level to vector aspiration level, keep the same proportionality model, and just play with those simulations. You get real life problem, real life data. You do not have real life decision maker, so you can replace it with this simple model and just see how it behaves, how it evolves. So the kind of first, how to say, I don't know if I can convey this idea. You can get any real life problem in dynamic, put it in dynamic setting. Maybe in some problem you have some potential continuation extension to dynamic. You only solve static problem because it's easier, but you just extend it to dynamic problem and you use that model of proportionality to see how it behaves in dynamics. And also, instead of proportionality, you just can consider other types of the functions between the past observed aspiration levels and achievements and new aspiration levels. For example, for me, I never understood this idea that you get weighted sum between observed achievement of performance and your past aspiration level. By this way, if you overachieved something, if you observe that your organization performed much better than you expected, then you get then the next your expectations will be weighted sum between what organization achieved and what you expected earlier. So it will be always lower than what organization achieved. But if I am manager, I would always go higher. I would just extend these parameters not between 0 and 1, but I would allow that this parameter will be greater than 1 to push organization forward. This kind of simple reasoning can be used to modify this model and to consider a bit different extensions. So this is one line. And another line is you do not consider dynamic settings where something happens in time, but you can probably try to use this model as the model of decision maker behavior, where decision maker solves one static optimization problem using some interactive method. So basically, because that reference to that paper which we got was the response to our paper where we produced automatic decision maker, it's not directly how it should be. Of course, it's different setting, but basically, if you are interested in creating some new models of how real life decision makers could behave when working with specific multi-objective optimization problem using interactive method, you can replace time in those models, t, with just iterations of the interactive method, and try just why not to think that in next iteration decision maker sets aspiration levels as the weighted sum between previous reference point and the currently obtained solutions. And from that, of course, it's not very justified from my point of view why decision makers would behave that. But because there exist very kind of big papers which are very well cited and very profound in good journals, you can just make references to those papers, and this could back up your research of this sort. So the second line is just reuse those models and use them as backup to justify your model of behavior of decision makers with interactive methods. And second idea, how can you utilize those models, is just as has been utilized in the last paper I shown you. You have some optimization paper which is not related directly to those dynamic models, to behavior of decision maker, proportional behavior. But if you read those papers, if you are familiar with that line of research, for example, what is the difference between the rational behavior when decision makers optimize and bounded rationality behavior when decision makers use satisficing concept. If you're familiar with those topics, with those problems, dynamic problems, you can maybe find place in your paper to make some very profound statement which would back up your basic ideas, and you can refer to those papers. So basically, that's all. I recommend you to familiarize with that line of research related to economic theory and to this classical approach and new bounded rationality approach, because I think it contains a lot of interesting ideas which can be indirectly used in your research. Yeah, thank you for attention.